is this? When you get the inverse of an exponential graph, the big idea is that that's the one place where logs are introduced in like your math. You see, when you have, let's say, y is equal to a third the power of x. You see, this is y is equal to this. So let me write it as f of x or g of x or something. So let's write it maybe as g of x just for the vibes. You see, there's g of x here. The inverse of g of x, what we know is for us to get it, we have to firstly x becomes y becomes x. You see, now with that being said, right, this is y. I mean, like, we already know this is what it looks like. Y is equal to this. So we're gonna swap them around, meaning that y here becomes x there becomes y. Now, the big idea now is that as long as we have swapped these, you see now we have y up there, which is our only problem now, because we want to make y the subject of the formula. Now, the easiest way, as we say, to make y the subject of the formula is just remember how the structure of your question looks like. There's a base here, and there's an exponent. So because y is an exponent, we don't want it up there. There's a base, there's an exponent, there's something on the other side. Let's maybe even label it like that. You see, you have other side here. It is equal to a base. It is equal to the power of an exponent. That's the structure of what we're seeing. So our job is to just make y the subject of the formula. We're trying to make this exponent the subject of the formula. So what you do is you do make it the subject of the formula. Your exponent is going to be the subject of the formula, and it's always going to then equal to the base. No. It's going to equal to the log, and whatever the base is, it is the base of the log, as we call it. And then whatever is on the other side, it's just going to be the number here, like always and forever, you see. So in this case, you can see that, okay, y is the exponent. So you're going to put y on its own, because that's the whole point anyways. That should be your reminder of when to use logs also, because you are seeing that, okay, wait a minute, here we're kind of stuck because we want to make y the subject of the formula, but y is an exponent. So as long as you see y is an exponent, think of logs. You see,
Okay.
when you see an exponent and you're trying to bring it down, think of logs. You see, because when you will bring it down, it is just going to be equal to log. Whatever your base was, it is now the base of the log. It's called the base of the log. And then whatever this number was, it's just going to come over there, you see. And then therefore here, you have your inverse function. If they say they want it in this format, you can write it. If they say they want it in terms of y, you can just leave it like that up there. Like this, you see. So that's logs, you see. We can even take it a step further and almost start with something you haven't worked on yet. Like this year, you haven't worked on financial math, right?
Not yet, but I think we are going to do it.
Yeah. So with your financial maths, there's a point where you're going to work with this equation. It's on your formula sheet as well. So you actually don't need to worry about it. It's an equation that looks like this. You see, this equation, there are cases where they want you to solve for n. You see, because with this kind of an equation for F4 for financial math, this would be like monthly installments, interest, and the number of payments. And this will be what you're trying to get at the end of those installments. Maybe you're like saving up. This is what you want to save up to. This is how much you're putting aside. This is your interest. This is how many payments you want to make. So normally they'll ask you to isolate n here. So you can imagine if you want to isolate n here, you can do algebra first. You see, by firstly getting rid of the denominator by multiplying by I here, multiplying by I there. Just going to give you fi on the left, and then here I cancels I. Then you're going to have the x with the bracket 1 minus I power n minus 1. We're trying to get n, you see, so we're trying to get rid of everything around n. So the next thing that goes out is x, because you always start from everything that's the furthest away from n. So this is the furthest it went away. This is also a bit far from n, so it's going to go next. So it's x times this big bracket. So to get rid of x, you're going to divide by x. So divide by x here, divide by x there, and then this goes away. And then you're going to have fi over x, the whole thing equal to now 1 minus I to the power of n minus 1, you see. So remember we said always get rid of stuff that are further from n first. So the negative 1 is going to go away first. So the negative 1 goes to the other side. You have fi over x plus 1 now. And then here you have your 1 minus I to the power of n. Now, if you look at it nicely, your structure that we spoke of up here is what you actually also have now. Other side, base, exponent. Because now we can see, okay, wait a minute, we're kind of home free now, because now we are one step from isolating our exponent, because our exponent is now, it's now visible. So there's you see something here. Let's maybe use a red. You can see there's something on the other side here. There's a base, there's an exponent. You see here we have something on the other side. We have a base and we have an exponent. So anytime you're able to get your equation to a format like this, you can easily isolate your exponent, because we said all we want at the end is the exponent on its own equal to a base, no, equal to log a base and whatever was on the other side. This is what we want to end up with, So it doesn't matter if we are just working with a small equation where it's just, x is equal to a third to the power of y. It's the same idea. There's still something on the other side. There's still a base, and our exponent is still like visibly on its own somewhere up there. And we want it to be the subject of the formula. So that's the idea here. Your next step, you can just now do exactly what you want to do. You want to make n the subject of the formula, which was your exponent, right? So you're going to equate it to log. Whatever the base was, it's this whole bracket here, 1 minus I. Whatever was on the other side, it's this whole thing here, fi over x plus 1, like that. And then your exponent is the subject of the formula. Do you see?
Yeah.
Yeah. So you don't want to put logs on a pedestal. It's just the same way if you have a x squared equal to like 9. To get rid of the square, you have to square root, and you end up with plus or minus 3. The same way you get rid of the square here, this is just also a method of trying to isolate your exponent. You see, it's just another method where instead of us having something where we can like square or square root, blah, 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 we just use a log to say, okay, fine, let's put log. Whatever the base was, it's going to be the base. Whatever is on this other side, it's going to come there. Because in your calculator, remember, if you look on your calculator now, if you're using the Casio calculator, right, under the on button, you have a button that says log. There's something here, and then there's something here. There's 2 log buttons. This is the one we use, you see, because the other one only just has log, and then just this thing here. This one that has something like this here, it automatically has a base of 10 here by default, like literally. So the one that does not have anything to put in here, it automatically what am I writing here? Automatically has a base of 10. This one can be any base. You see, that's the only difference between those 2 buttons in your calculator. So that's why we mainly just use this one, because now we can put our own numbers as our base and our own values here that will come here. And then we can just work on it like that without worrying about anything extra or anything fancy.
Cool. Got it.